Hi, this is Mr. Ward, and I'm going to talk about exponential functions level 2. And level 2 is going to talk about zero and negative exponents. And I've put a lot of resources in here, some practice and so forth. And there's some notes. There's a little summary of exponent rules, which gets into some further stuff, but it gives you a pretty basic understanding of what a zero or negative exponent is. So those are resources for you. But I want to go back to the idea that an exponent is a number, a notation that tells you, I should say, could be a variable. It's a notation that tells you how many times another number, which we call the base, is going to be used as a factor. So I'm going to go into Desmos and I will talk about this because that makes sense with a positive number. But what happens if it's a negative number? What happens if the exponent is negative, I should say? What happens if the exponent is zero? And later on, I'll get into what happens if the exponent is a fraction. So let's consider our 2 to the third power, which here is 8. Okay, because that we already explored that. That's right up there, represented by 2 times 2 times 2. Okay, so move this over here because I don't need it over here. So we got 2 to the third power. What would it mean for it to be 2 to the negative third power? Well, to get there, let's actually take a look at what 2 to the third power would be, and then 2 to the second power would be, and 2 to the first power would be. Uh, and so what happens is, notice each time I take away one factor. So I'm going down 2 to the third. In fact, I could put in let's go ahead and put in a 2 to the fifth, which is 32, and 2 to the fourth, which is 16. And so I go 2 to the fifth, I take a factor away, which means divide by that factor. In other words, divide by 2. So as I go down from here to here, I am dividing 2 to the fifth by 2 to get to 2 to the fourth, which is 16, which is 32 divided by 2. And divide 16 by 2, I get 8, which is 2 to the third. And then if I divide 8 by 2, I'd get 4, which is 2 to the second, 2 times 2. And then I divide 2 to the second, which is 4, by 2, I get down to 2. So a first stop on our way to negative exponents is to look at what happens if I take away that last factor and I divide that 2 by 2. Now you might be thinking, oh, well, 2 divided by 2 is 1, and you'd be right. 2 to the 0 power is 1. And in fact, every number, with the exception of 0, that is raised to the 0 power to an exponent of 0 equals 1. Why isn't it 0? Well, there's a lot of different reasons. One is this: it's consistent with this pattern. It is actually formally a mathematical definition rather than um, a mathematical relationship in the way that 2 to the second is 4 because 2 times 2 is 4. We have defined it this way because it fits a lot of patterns. 5, I'll put some other numbers in here. 5 to the 0 power is also 1. Change that base to 55, 255, 2.55. But, of course, I did mention Desmos thinks 0 to the 0 power is 1 as well. Mathematically, this actually has been defined not as 1. 0 to the 0 power is considered undefined because some approaches lead it to be 0 and some approaches lead it to be 1, and they're both quite sound and they're contradictory. So we set aside 0 to the 0 as undefined. There is debate in mathematics about that, but you won't have to encounter that very often. But most of what we'll deal with is just other numbers than 0, non-zero numbers. Negative, I put that 2 in parentheses, negative 2 to the 0 is also 1. Okay, so let me go back to my 2 to the 0. Now, 2 to the, let me go back up here. Let's start with 2 to the third. 2 to the third is 2 times 2 times 2. Then 2 to the second is 2 times 2. And 2 to the first is 2. Okay, so I took away that last factor of 2 and I get 1. Why would there be a 1 left behind aside from this pattern? Well, one thing to know about multiplication is there's always a 1 as one of the factors. It's a hidden one. I like to think of it as the ninja 1. It's always in the background. As long as other factors are there, you don't necessarily see it. In fact, there's an infinite number of 1s there. But what happens when I remove that last factor of 2, what's left behind is this 1. So when I remove that last factor of 2, there's a 1 left behind. So 2 to the 0, 5 to the 0, 18 trillion to the 0 are all considered 1. The only set aside is 0 to the 0, which has some problematic aspects to it. It is considered undefined, even if Desmos says it's 1. All right, that's 0 as an exponent. To the 0 power equals 1 unless the base is 0. Why? What do we get? What do we do with negative exponents? Well, there are a couple things to keep in mind. One thing to keep in mind is the 1. Okay, so the 1 is going to be a starting place as we go down the pattern. So remember, each step along the way, we removed a factor of 2. So if I say 2 to the negative 1 power, I'm going to be taking away a factor of 2 from 2 to the 0. Okay, if I'm taking away a factor, that means I'm dividing. So 2 to the negative power, 2 to the negative first power, means I'm doing 1 divided by 2. I'm actually going to use the keyboard down here. I don't usually do that. 1 divided by 2. Notice it just turns it into a fraction anyway. So that is 2 to the negative 1 power. 2 to the negative 1 power takes the 2 and turns it upside down. How about 2 to the negative 2 power? Well, 2 to the negative 2 power gives us not 1 divided by 2, but 1 divided by 2 divided by 2 again. So instead of telling us how many factors we're using, it tells us how many times we're using 2 as a divisor. So that's 1 over, that I didn't work out the way I meant it to, 1 over 2 divided by 2. Okay, and then I make that. If I wanted to do 2 to the negative 3, that divided by 2, and 2 to the negative 4, that divided by 2, and I get there. Okay, and so I'll confirm that, 2 to the negative 4 power. Another way to write that, though, would be 1 over 2 times 2 times 2 times 2. And so another way to think about 2 to the negative 4th is 1 over 2 to the positive 4th. And so now we get into the role of a negative exponent to turn a number upside down, to flip it into its reciprocal. This is 2 over 1 to the negative 4th. And I get 0.0625, or 1 over 16. That 2 times 2 times 2 times 2 is 16. So this is 1 over 16. Now 16 is 2 to the 4th. So notice that when I moved my base and exponent across the fraction bar, the sign changed, but it kept the value the same. Okay, that actually works in the other direction as well. I could say 1 over 3 to the negative 2 power, which is going to give me 9. If I move that 3 across the fraction bar, 3 over 1, and I make that to the positive 2 power, I get 9 as well. So anytime you move the exponent, the exponential expression, across the fraction bar, it changes the sign of the exponent. And the negative exponents flip or cause a reciprocal to happen. A reciprocal is a fraction that has been turned upside down. It is, so the reciprocal of 8 is 1/8. The reciprocal of 2/3 is 3/2. You turn it upside down. You're basically the formal definition of a reciprocal is a number that you would multiply by to get 1. And so 2/3 multiplied by its reciprocal, 3/2, would make 1. So these negative exponents reciprocate. So I'll demonstrate with 2/3. So 2/3 as a decimal is 0.6 repeating. Okay, if I raise that to a negative 1 power, now I get 1.5, which is 3/2. So I have simply flipped that. And then if I raised that, I'll put it in parentheses, raise that to the negative 1 power, I go back to 2/3, which is 0.6 repeating. Okay, and if I were to raise that to the negative 2 power, I get 2/3 raised to the positive 2 power, which would end up being 2 times 2 over 3 times 3, or 4/9. All of those are the same thing. All right, so I'm hoping this has helped a little bit. If not, check out some of the other resources. Ask me questions in class, and let me know if there's some details you'd like me to go over in an additional video. All right, thank you very much.